Alright, hello everyone, it's July 5th. Alright, find the minimum and the maximum number of nodes between critical points. Critical point in linked list is defined as either the local maximum or local minimum. A node is a local maximum if the current node has a value strictly greater than the previous and the next. The local minimum is the other way, right? Note that a node can only be a local maximum if there exists both a previous and next node. Given a linked list, return an array of length 2 containing the minimum distance and maximum distance, where the mean distance is the minimum distance between any two distinct critical points, and max distance is max distance any two distinct critical points. If there are fewer than two distinct points, return -1, -1. Oh, so that's a local minimum, that's a local maximum, and that's a local minimum. So the minimum will be 1, maximum will be these two, right? The third and the 6th. So I just keep a pre value, right? So when we start, it doesn't have a pre value. So we have a pre value, then we check this one, right? And now we check the next. So it's not pre, right? And then we move on to this. So I have a pre, have a next. So this is, so I count. Yeah, so I have an array for position. So I have its position. I want to call it 1, 2, 3, or 0, 1, 2, and 3, 4, and then 5. So we'll do that, right? And the maximum is just the front and the end. Minimum has to be going through consecutive, right? We have to go through consecutive. Okay, I'll give it a shot. Oh. Maybe we can do it along the way as well. Okay, let's do it along the way. So call index first. We don't know what first is. And then okay, while node dot next. Okay, I know dot next is not equal to no. Pre-val. I need to set this to -1. So I also have a pre-index. Pre-index should be pre-index. Pre-index. -1. Okay. If node.val is larger than, wait, is it larger can be equal to strictly greater, strictly so. So node of val larger than pre-val, and node of val smaller node dot next larger than dot next dot val, or yeah, I probably need to do this. Right. If this is true, then we have we need a returner. Into 2. Okay. All right. So first is minimum and a maximum. Okay, minimum and a maximum. Actually, I think we probably can just minimum and maximum. Oh, that's not right. We want the minimum. Oh. And if only one of them exists, that's not going to work, right? Fewer than 2 points. Fewer than 2 points. We can handle fewer than 2 points. All right. We should say if pre-index is larger than 0. If first is smaller than 0, then first will equal to index. Actually, this should be 1. Right. If first is smaller than first equals to index. If pre-index is larger equal to 0, then we can compute. I will compute it and then we put it in res. Equals current index minus pre-index if res 0 is smaller than 0. Res, I can't do this. Res 0 should equal to res 0 smaller than 0. If it is, we just do d. Otherwise, we do mass down minimum res 0 and d. Okay, that's if pre-index is smaller larger than the 0. If pre-index is smaller, then we don't do this. Okay, so we handle both. So now we'll say pre-index shall equal to index, and pre-val shall equal to node.val plus equal to node.next. Okay, when we get to the end, all we want to know is your index. Actually, index shouldn't be here. Index, okay, I should do plus plus here, right? If we only have one, then we'll have pre-index, right? And that's it. We'll have preval. And first. So if first is equal to pre-index, right? Because if we have 2, then we'll have the second one, right? We'll have the second one. Or is it even... No, I think if there's only 1, I'll hit first, pre-index will be still smaller, so I don't hit the result. And then if nothing, then we just, I think they can just return. Okay. A shot. Oh, that's not right. Yeah, I have to handle the last. So I have a first. Last will be index. Alright, so we shall say if index is larger than 0, index will be larger than the first. How do I know we only have 1? We only have 1 if the first and the pre-index is the same, right? Because if I have 2, pre-index will be the second one, so yeah. Oh yeah, it's pre-index because at the end is pre-index, so we just do pre-index and first. So if pre-index is larger than first, then res1 shall equal to pre-index minus first. Okay. Okay. We have a little bit issue, but we can probably deal with this. Output is 2. Interesting. So 0, 1, 2, 3, 4, 5. Yeah, pre-index is larger or equal to 0. Okay, I don't know why, but I'd like to try what happened here. Let's say we do pre-index. Let's take a look. Pre-index is 1. Pre-index is 1. Yeah, we start index is 1 because that's what we start, right? And then it's bad. No, it's right, -1, 1. And come back up, so it's going to be here. Index moves to 2. Pre-index is this. Oh, index, you always point at 1. Now, index should move every single time. You are moving forward. Pre-index equals to this. Yeah, index should be plus plus as well. Sorry, index should be plus plus as well. There we go. Index is actually index. All right, so we have the last one. Have some issue. Okay, that's fine. So I got 1 and 6. This doesn't make any sense, huh? Index. 1 1. Pre-index. Yes, 1 1. 1 2. 3 3. 3 3. Huh? 1 1 is right. Okay, and then move on to 2. But 2 doesn't work out, so it's 1 2. So it should be 1 3. And this shouldn't come. What happened? How come it becomes 3, 3? That doesn't make any sense. Huh? What? Okay, preval is 1. Node is this. So no val larger than preval, no val larger than node dot next dot val. Okay, so first set to 1. Pre-index is smaller than 0, so pre-index smaller than 0, so I don't do the result. Yes. So pre-index equal to 1. Pre-value equal to 3. Right? Pre-value equal to 3. Oh, the pre-value was wrong. There we go. Oh my. Oh my, a lot of trial and error. Yeah, I won't say it's hard, but since I try to do it using O1 extra space, it's a little complicated. A little bit. 2058. Since I try to do this with O1 space, the logic is a bit convoluted. One important thing to note is that pre-index is set, right, when a critical node is encountered, yet pre-val is set every single node visit. That's the key. Alright, try this. Yeah. I think not using extra space is definitely commendable. One pass. Yeah, I see, it's like, it's not straightforward. Okay, that's it. I'm not doing another one, and I'll see you